super interesting research paper to me, and it again gets to blend that philosophical and academic lines. So this is beautiful territory for me. Universal Approximation Theory, the basic theory for large language models. This is put out by the Hong Kong Polytechnic University. I'm going to make a comparison to this paper, and I think it's an apt comparison in regards towards exactly what this paper does for this particular area of science. And so the comparison is the fact that, like, pre-theory of relativity operating within the physics realm was completely different, right? There was not a unified theory of physics. If you were talking about time and space, or time or space, you could talk about time or space, and they weren't necessarily related and conjoined, and they weren't grounded within physics 100% until the theory of relativity summed it all up into a unique package and said, hey, it is all joined together, right? Here's the proof that it's all joined together. And then so with universal approximation theory, essentially the getting down to the root of this paper, you've heard me talk about this concept before, if you've heard me talk about these concepts a bit, which is complexity theory. And then so complexity theory is essentially like and universal approximation theory is essentially the foundational work and framework for how AI works, right? So it's essentially, it starts off with the perceptron, and the perceptron is what is now the modern transformer. But so the initial thought was very simple, right? Which is that you take a bunch of neurons, and that these neurons, the fact it's not that the neurons do anything special, like that there's not a unique mechanism about a neuron. It's the fact that you have multiples of them firing together, and that you get relationships between the neurons, and that you get that strengthening of the relationship, and that there's something within that, right? And so that's universal approximation theory. And then so that's how and why perceptrons are formed. And then so they're based off of a simplified neuron, and then you go from there. And then, but so what happens is, and they mention it very distinctly within this paper, is that there's a schism at some point between that, like the basis of the perceptron and universal perception theory, and universal approximation theory, and the fact that, like, advanced neural networks don't necessarily, like, it's harder to mathematically equate them back to universal approximation theory. You start to get that kind of that schism of time and space, right? And it, like, are they 100% related? Are they grounded? Like, you're in this pre-relativity phase of physics within regards towards the AI space, and with regards towards like large neural networks very specifically. And then so what this paper does is essentially provide that gap, right, the gateway between the two, and says that there is a correlation, a mathematical correlation between large neural networks and like perceptrons and the beginnings of neurons. And kind of to highlight and go into like why that schism exists. So it exists mathematically, right? Like there's and so that's what they solve. They solve and they prove like the mathematical equation. Like, here's the missing link, right? Like if this were an archaeological discovery, this would be like the missing link between Homo sapiens and monkeys in evolution, right? Like this would be like this is the definitive missing link. Like there's a 100% causal chain, and like here's the like one in the middle, right? And then so the difference though is that so you have the perceptron. The perceptron works, but the major difference between the perceptron and the transformer, and there's a few differences, right? But like one of the major, like the huge breakthrough that happens it's in the 1980s, and by Geoffrey Hinton, one of the godfathers of AI, is the invention of backpropagation, right? Backpropagation in 1986. And then backpropagation is unique because essentially it's very simple, right? So it's you feed the prompt forward to the model, and then you take that same output, and then before it generates the output, you feed it back to the model, and so you feed it back over the weights, right? And that's how the model generates its outputs now, and to this day, it utilizes backpropagation. But So like the thought and the theory is it's held since then is that like so but that back propagation like that one it changes the math, and then two it changes the physical way that that model is actually thinking and learning overall, right? Like uh, our brains don't have a back propagation mechanism. There is nothing within the neuron that can make it fire backwards. So it's a completely different element within um, like neural networks at that point, advanced neural networks, as opposed to the brain. Like there's just nothing that's comparable to the two. And then so that's where you start to get those schisms. Well, it's not actually like not actually the same. And then it's like you start getting the question like, is it actually Hebbian learning, right? And then that's like kind of the big question, like, is back propagation and like are these models like actually partaking in this Hebbian learning process? Is that actually what is going on? Are they grasping the information, right, or are they just stochastic parrots? And then that whole conversation within it, and then there's been a big class of this argumentation that has stood behind the fact that back propagation exists, and then so therefore because back propagation exists and because of the fact that we can't mathematically link the transformer back to the perceptron, then that there isn't a correlation and that there's not actually Hebbian learning taking place within advanced neural networks. And then, but so what this paper is showing, and overall very clearly and mathematically, if you want to, like, I try to avoid the like, I figure that nobody wants to ever talk about and discuss like mathematics and diamond matrix multiplication and like advanced matrix multiplication in depth, right? And I do talk a lot about like, so I make videos in depth about matrix multiplication, and like AI models, they all come down. It's all about matrix multiplication, right? You have to understand this concept to understand AI, because it's just this concept duplicating on itself over and over again. And then so once you understand this concept, you understand the whole concept. And that's all it is, right? These are matrix tables, and then so like it's just this duplicating on itself over and over and over again. It's just multiples of these stacked on each other and stacked on each other and stacked on each other. But so essentially, that introduction and that change, the only change within that is that backward sequence, right? But then that backward sequence changes everything, and then so now you get to this equation, and this equation is essentially linking that backward sequence to the overall process. And then so that's where I'll end it as far as the overall discussion of this paper. It's all mathematical from here. But so kind of the last place that I will link and talk about, since it's my channel on this in this discussion, is that I have thought about this before, and like so my thoughts and like what I have come back to like within my thinking a lot when I try to think about this from a philosophical realm, like I think about it like pigeons, right? I keep coming back to pigeons. Pigeons think differently than like other animals and even other birds. You can tell like there's something different that goes on in their brain and their logical brain processes. And then to me, like I don't know, like I imagine that in their brain there's like a back propagation process that occurs, right? Like it's kind of like I don't know, it's kind of weird. Like you can see like they have like a click in their brain, like their brain they just there's something going on different with pigeons. And then, but you can't say that they're stupid though. Like if you look at studies, like they're very intelligent. Like they map out cities. They'll use crosswalks, things like that, right? And then so there's a different intelligence that's going on within pigeons. And then so to me, I've always likened it to more of a back propagation type of process. And then so my overall thought in bringing that up is not to equate like advanced neural networks to pigeons, and then to say or to assert that there's a correlation there, because I don't know if there's a correlation, but it's that same type of process, right? The fact that like intelligence can assert itself in different ways. Don't lock yourself into human intelligence, and then like that's a big thing. Like a lot of people say that like they don't anthropomorphize models and like don't anthropomorphize overall, right? I think that's 100% true. I think a lot of people they use those arguments very dismissively, which is why I don't like them, because they're just like, oh, you're anthropomorphizing. But it's like you can do you should not anthropomorphize at all, and you can actually take it a step further than that and like look at it as more freeing than like AI models, like they don't have to be resemble like a human exoskeleton. Like they could resemble like an octopus exoskeleton, and they don't have to resemble the way that a human brain works. They could resemble the way that a pigeon brain works, etc. And then it doesn't have to be biological processes as well, right? That's another way to like. You don't want to pigeonhole yourself into any area. I guess is like the major part when you're talking about these discussions, and not and making sure that you don't anthropomorphize. But with that, I think that this discussion is getting a little bit further away from this paper overall, which is an excellent paper, very mathematically dense paper, which is why I've tried to stay away from that. But like, I can't understate the significance of this paper. To me, overall, this is like the theory of relativity for AI. So great job to the Hong Kong Polytechnical University, and thank you for this paper, Universal Approximation Theory, the basic theory for large language models, and I'll leave a link to this paper in the description. Thank you.